Okay, so this is our notes for Friday, and I hope you guys all enjoyed your service day. Quarantine people, I just want to let you know that if you have questions during these next couple of weeks when you guys need me, um, always know that I don't have students between 1:15 and 2 o'clock, so I will try my best to have videos pre-recorded so that way you can watch those in the mornings, and then during my prep if you have questions just let me know. But I do want you guys to know that I will do my best to be available for you guys. It's looking like next week, I'm looking at my calendar, and it looks like I'm pretty free except on Thursday next week. So if I need to do like a FaceTime after school or in the evening, if you guys get a hold of me, we can definitely make that work. So today we are actually going to do residual plots. So we're still going to do the residual tables like we were doing on the graphing calculator before all of you guys were gone. And if we can see here, we have observed values and we have our x's. And I'll explain what this plot over here is in just a second. So whenever we are doing residual plots, we are actually going to compare the predicted value and the observed value. So the predicted value comes from the equation, and I'm trying to find a different color pencil so that way it looks nice. All right, so the equations go right here, and whatever we get here is going to be our predicted value. So if you guys remember, on our calculator, we can actually set up our list. And you can do this by hand as well, but I just want to remind you with the calculator instructions, we can go to stat and we can edit our list. Now, so I need to go through and clear our stuff that we were doing. Oh no, I messed up. Second plus 712. Okay, I deleted a list on accident. So now when I go into my edit, everything is clear. All right, so I'm going to type in my x's. All right, 5, 10, 15, 25, and 30. Now I'm going to go over here. This is my L1. This is going to be my L2. I need to find a better pen. All right, so we got 3, 3, 4, 9, 7, 13, 15. All right, so whenever we look at these residuals, we are going to see where the dots compare to the predicted values. So remember, if we want to put this in L3, we can simply write, on L3, we can write, since it's 0.5x, we can actually do 0.5, but the x values came from L1, and then we don't have a b value. So we can simply just go up to L3, highlight it, and then once it's highlighted, we can actually type in 0.5, and then you can do parentheses, or you can just put L1 right in. So L1 is in blue right here above the 1, so we just hit second and then the 1, and then our L1 shows up and we hit enter. And it plugs in every single one of those values. So if you can see here, we are essentially taking half, exactly what we're doing. We're taking half of every x value. So we get a value of 2.5 and 5, 7.5, 10, 12.5, and 15. So the residual comes from the observed minus the expected or predicted. So I do want you guys to know that sometimes in predicted value, you also hear that to be the expected value. If you hear both of those words, they mean the same thing. So remember, to get the residuals, we take the observed minus the predicted or the expected. So in L4, we could subtract these, which you guys know. 3 minus 2.5 would be 0.5. 4 minus 5 would be -1. You could do this by hand, but I just want to review the calculator. If you want to calculate the residuals, especially if there's crazy decimals, you go into L4 and we take L2 minus L3 and hit enter, and it'll spit all those out for you. And you can see 0.5 and -1 that we did by hand still show up. And then our remainder, just to save you on calculations, we have this. All right, so these are the residuals. So if we're looking at this, this is telling you when x is 5, we're 0.5 above the trend line. When x equals 10, we are -1 below the trend line. When x is 15, we are 1.5 above. At 20, we're -3 below. At 25, we're at 0.5 above. And when x is 30, we are actually right on the line. So we are still going to do our x's on the x-axis, but when we do a residual plot, we are actually going to plot the residual plot compared to the x's, not these two. So we could look at these on a trend line, but we're not going to today. So 5, 10, 15, 20, 25. All right, so right here, this is when x is 0, and I'm going to count by 5s. And then I'm actually going to just extend out a little bit so we can have an x is 30. All right, so I'm just going to extend that out just a little bit. All right, so when x is 5, the residual was 1/2 above. So we know that 1, 2. Let's just count by ones. +1, 2, 3, negative, and that would be 0, -1, -2, -3. So on our first one, when x is 5, our residual was a +0.5, so we're going to go in between 0 and 1. When x is 10, it tells us our residual was at -1, so we're going to go over when x is 10, the residual was -1. Then at 15, it was 1.5, so we're going to go in between 1 and 2. At 20, it was -3. At 25, it was 1/2. And at 30, it was 0. All right, so whenever we are looking at residual plots, it's asking you if it suggests a linear relationship. And on this one, if you can see, we have a few points above, a few points below. We have one on the line. It's not totally skewed. Whenever you are looking for a linear relationship, you should see no correlation on these. And so we want our residuals to be evenly spread above and below, kind of all the way throughout. And we're not doing too bad here because we go above, below, above, and then on. So that's not too terrible. This point out here kind of throws it off a little bit because it is farther away. You know, if it had been moved up here, we would have definitely said, yes, it's a strong linear relationship. We could say here, yes, it's linear, but probably a little weaker. So it's linear, but is a weaker relationship. And so we are just comparing residuals, and for it to be linear, we want to see all throughout the graph above and below. We don't want to see like a U shape or a line like where we're all below and then all of a sudden we're all above. We want it to be evenly spread throughout, because whenever you're looking at a scatter plot, your goal, and I don't even know if this is the scatter plot, but I can draw it on here. So whenever you have a scatter plot, isn't your goal on a scatter plot to have points kind of evenly spread out above and below? Like you want things above. So you're basically taking a scatter plot and you are rotating it to where this is the average. That's the residual of 0, and you have some above and some below. So I want to take a look at number 2, just so we can get in the practice of, and I'll say this is the first time I've used this camera, so just bear with me. I'm hoping that it shows up nice and neat. All right, so on this next example, we have a new equation, we have a new list, so we can go ahead and get our new list plugged in. So I'm going to just set that up. All right, so we're going to clear our list. We're not going to delete our list. All right, so we got 2, 4, 6, 8, 10, and 12. And our y's are 5, 15, 26, 23, 11, and 3. All right, so we've got those in. So for this one, our predicted value for L3, we want to say negative 0.4. X is from L1 plus 16.3. That's what we're going to plug in. So we are going to type in L3, highlight it, negative. We got to use, all right, so whenever you're doing your equations, don't forget, and I'll say, sorry, this Zoom is absolutely terrible. There we go. All right, so don't forget when you're typing a negative button, you do have to hit that negative down here. Do not hit the minus sign. You'll get an error. So negative, and our equation here is 0.4 times L1, and then plus 16.3. And that's going to give us our answers for plugging in each X value. So if we plug in 2, we get 15.5. Plug in 4, we get 14.7. So I'm just going to copy my values down. All right, and then for our residual in L4, we are going to take our observed from L2 minus our predicted in L3. L2 minus L3. And we get some negatives and some positives. And we'll see. All right, so our X values count by 2. So do we have enough room to do all of those? 2, 4, 6, 8, 10. I'll say this was not the greatest chart. You would think they would have that to go right in. All right, so our X's, 2, 4, 6, 8, 10, and 12. And then our Y values, we have things going all the way up to 12. So let's see, 2, 4, 6, 8, 10. Now let's go ahead and just count by 2, or yeah, we can count by 9s. 3, 6, 9, 12, 15. That's 0, negative 3, negative 6, negative 9, negative 12, and negative 15. All right, so you do have to figure out your scale. So I just looked over here and I knew that I went by 12s and it only went up 5. So I couldn't count by 2s because I was going to run out of room. I just counted by 2s on the x-axis because those were the numbers that were right there. I don't really like to, I try to stick with the ones that I see, but we can count by 3s and that's okay. All right, so when x is 2, our residual is negative 10.5. So we're going to go a little bit below negative 9, not quite to 12. At x is 4, it's 0.3, very close to 0. At 6, it's 12.1 positive, so we're going way up here. Then when x is 8, we're at 9.9, just a little above 9. At 10, we're at negative 1.3, so it goes here. And when x is 12, we are at negative 8.5, so almost a negative 9. So if you can see here, on that last example, it kind of, you know, it was above, then it was below, above, below. Like it kind of followed a pattern. Like we had above and below all the way across. Here we have 1 below, and then we have 3 above, and then 2 below again. And so on this one, we definitely would not say that this is balanced because it almost like it has a pattern with it instead of no correlation. So this one we would say that this is not a linear relationship. Now I do want you guys to see what the actual scatter plot looks like, and this is things that we've done. So I am going to turn on my stat plot, and I'm going to turn on my stat plot here. And if you guys can see, I got my list in L1 and my Y list in L2. And I'm going to hit graph, and I'm going to zoom 9 so I can see it all. So if you guys can see here, This is our stats for our scatter plot. It is not linear, it is quadratic. And if we wanted to type in that line of best fit we were given, the y equals negative 0.4x, oh, that's not what I wanted to do, x plus 16.3, and graph it. You can see that line. Do you see how similar we are here to our graph? So we have a trend line, and if we like rotated it to basically make that trend line even with our, we got one below, one barely on, and then up and down. So this is definitely not a linear relationship. All right, so I want you guys to actually pause the video, and I want you to try to do number 3 by yourself, and then whenever you're ready, hit play. Make sure you do it in pencil, so if you need to make changes, you can. But I want you guys to try to do this one on your own and then reach out to me if you still need help with this. But I'm going to work this out, and then we will get started. All right, so let's see. All right, so if we look at this, this is a really strange thing. Whenever you plot this out, these points look linear. But if you are basing it off of this regression equation, if you can see all of the points are above, we have no points below the line. So on this, I do want you guys to see if we were to look at our graph. Oh, I got to fix my trend line. All right, so I've got a trend line and I've got some graphs, so I'm going to zoom, and if you see, I hit my stats. My stats are linear, but my trend line doesn't match up to it. All of my residuals are above, and so on this we would say the residual plot does not suggest a linear relationship. No, and to be honest, I really don't think that's a good line of best fit. I think that maybe if we had a different regression equation, we would have been able to do a little bit better. So I actually want to go through. I want to see what the regression equation for these really would be. All right, the regression equation the calculator tells me would be this. We might like this one a little better. So if this had been different, obviously we would have had different answers here, and different residuals, and it probably would have looked a little bit nicer. So we always have to make sure the residual plot on this one didn't suggest a linear relationship because all of the residuals were positive. None of them were below the line. So what this was suggesting was that we have a trend line and all of the points are above, which that would be a horrible trend line. But it didn't suggest a linear relationship, but when we actually looked into it, it really was. This was just honestly a bad trend line. So those are some things that pop up. Sometimes estimations are wrong. We didn't like that one. We like this one a little better. So this is what our new part of today is just doing a residual plot. And I am going to now I think I'm going to wait until everyone's back to bungee some Barbies. So next week's going to look a little bit different. You guys do not have homework over the weekend. I just want you to get these copied, and if you have questions about anything, don't hesitate to reach out. Have a good weekend, and I will hopefully see you all soon.